The universe is everything that exists. It includes all stars, planets, galaxies, space, time, and matter. Scientists believe the universe began about 13.8 billion years ago in an event called the Big Bang. At that moment, space itself began to stretch outward. Since then, the universe has continued to expand, allowing galaxies to move farther away from one another. For many years, scientists assumed that gravity would slowly reduce this expansion, because gravity pulls things together. However, discoveries made over the past few decades have shown that the universe is behaving in a much stranger way than anyone expected. In 1998, astronomers made a discovery that completely changed our understanding of the universe. While observing distant exploding stars called supernovas, they found that the universe was not slowing down in its expansion. Instead, it was expanding faster and faster. This acceleration could not be explained by gravity or ordinary matter. To explain this surprising result, scientists proposed the existence of a mysterious force they named dark energy. Dark energy cannot be seen directly, but its effects can be observed through the movement of galaxies. Today, scientists believe that dark energy makes up about 2/3 of the entire universe, making it the most powerful influence on how the cosmos evolves. For more than 20 years after the discovery of dark energy, most scientists believe that it was constant and unchanging. According to this view, dark energy would continue to push galaxies apart forever. Over trillions of years, galaxies would become so distant from one another that the night sky would grow dark, stars would burn out, and the universe would slowly fade into a cold, empty state. Some theories even suggested a dramatic ending called the Big Rip, where the expansion becomes so strong that galaxies, stars, planets, and eventually even atoms are torn apart. This idea became part of the standard model of cosmology, which is the main scientific explanation of how the universe works. However, new research published in 2025 has raised serious questions about this long-held belief. Scientists using powerful telescopes and advanced instruments have found evidence suggesting that dark energy may not be constant after all. Instead, it may be changing over time. If this is true, then the future of the universe could be very different from what scientists once imagined. Rather than expanding forever, the universe might slow down, stop expanding, and eventually collapse back into itself. This possible ending is known as the Big Crunch, and it represents a complete reversal of what many scientists thought was certain. The first major sign that something unusual was happening came from data collected by the Dark Energy Spectroscopic Instrument, commonly known as DESI. This instrument is located in the Arizona desert and was designed specifically to study dark energy. DESI can observe the light from millions of galaxies at the same time and measure how fast they are moving away from Earth. By studying galaxies at different distances, scientists can look back in time and see how the expansion of the universe has changed over billions of years. When scientists analyzed the data from DESI in early 2025, they were surprised by what they found. The results suggested that the acceleration of the universe might not be increasing in a smooth, steady way. Instead, the data hinted that the strength of dark energy could have risen in the past and may now be decreasing. This idea goes against the standard model of cosmology, which assumes that dark energy has the same strength at all times. According to Professor Ofer Lahav, a scientist involved in the DESI project, if dark energy truly changes over time, then scientists may need to rethink some of the most basic laws of physics. At first, many astronomers were cautious about accepting these findings. Extraordinary claims require extraordinary evidence, and the idea that dark energy could change is one of the biggest claims in modern astronomy. However, the debate became more serious later in 2025 when another study appeared that supported the idea of changing dark energy. This second study was published by the Royal Astronomical Society and was led by Professor Young-wook Lee from Yonsei University in South Korea. Professor Lee and his team decided to re-examine the same type of supernova data that led to the discovery of dark energy in 1998. Are useful because they act like cosmic measuring tools. By knowing how bright a supernova truly is and comparing it to how bright it appears from Earth, scientists can calculate how far away it is. This method has been used for decades and is considered one of the most reliable ways to measure cosmic distances. However, Professor Lee's team believed that one important detail had been overlooked in previous studies. They focused on the age of the galaxies in which the supernovas occurred. Galaxies can be young or very old, and the stars within them can have different properties. Professor Lee's team argued that supernovas exploding in older galaxies might behave slightly differently from those in younger ones. When they adjusted the data to account for galaxy age, the results changed dramatically. Their analysis suggested not only that dark energy changes over time, but that the acceleration of the universe is actually slowing down. If dark energy is weakening, the consequences for the future of the universe are enormous. Dark energy works against gravity. While gravity pulls matter together, dark energy pushes space apart. For billions of years, dark energy has been strong enough to overpower gravity on the largest scales, causing galaxies to move away from each other. But if dark energy continues to weaken, there may come a time when gravity once again becomes the dominant force. When that happens, the expansion of the universe could slow down, stop, and then reverse. This reversal would mark the beginning of a collapse. Galaxies would begin moving closer together. Over vast periods of time, the distances between all objects in the universe would shrink. Temperatures would rise, matter would become denser, and the cosmos would move toward a final state where everything is crushed together. This scenario is known as the Big Crunch. In this ending, the universe would become extremely hot and dense, possibly similar to the conditions at the beginning of the Big Bang, though scientists are not sure what would happen next. Not all scientists agree with Professor Lee's conclusions. Some argue that supernovas are complex events influenced by many factors, and that correcting their brightness based on galaxy age may introduce new uncertainties. Professor George F. Stathiou from the University of Cambridge has expressed skepticism, saying that the relationship between supernova brightness and galaxy age is not strong enough to justify such corrections. According to him, the results may reflect the messy nature of supernovas rather than a real change in dark energy. Despite these criticisms, Professor Lee strongly defends his work. He points out that his study analyzed data from about 300 galaxies and that the statistical significance of the results is extremely high. According to his calculations, the chance that the findings are a random error is incredibly small. While this does not prove that dark energy is weakening, it does suggest that the results deserve serious attention and further investigation. Since these studies were published, many other research teams around the world have begun re-examining the data. Some have found that the original results are slightly weaker than first reported, but the strange hints remain. The idea that dark energy could change over time has not disappeared, even after intense scrutiny. As a result, the scientific community is deeply divided. Some believe that the universe is still expanding at an ever-increasing rate, while others think that the cosmos may be heading toward a very different fate. This debate highlights how science truly works. Scientific knowledge is not fixed or unchanging. Instead, it evolves as new evidence appears. Ideas that once seemed certain can be questioned, tested, and sometimes replaced. Disagreement among scientists is not a weakness, but a strength, because it leads to deeper investigation and better understanding. As Professor Robert Massey of the Royal Astronomical Society has said, it is natural for humans to wonder how the universe began and how it will end. These questions connect science to philosophy, history, and even religion. What makes this discovery especially fascinating is that dark energy remains one of the greatest mysteries in science. Scientists do not know what dark energy is made of, where it comes from, or why it exists. They only know that it affects the way the universe expands. If dark energy is changing, then it suggests that the laws governing space and time may be more complex than we currently understand. It could even mean that our understanding of gravity itself is incomplete. For ordinary people, this research may seem distant or abstract, but it touches on very deep ideas. Everything we see in the night sky, every galaxy and star, depends on the balance between gravity and dark energy. The future of all matter, including the atoms that make up our bodies, is tied to these cosmic forces. Whether the universe ends in endless expansion, a violent tearing apart, or a dramatic collapse affects how we understand our place in existence. At present, there is no final answer. The universe will not end for billions of years, and scientists are only beginning to uncover the true nature of dark energy. Future telescopes, better instruments, and more precise measurements will help clarify whether dark energy is constant or changing. Until then, the debate will continue, pushing science forward and reminding us that the cosmos is far more mysterious than it first appears. In the end, this story is not just about galaxies or equations. It is about humanity's desire to understand reality itself. From ancient civilizations looking up at the stars to modern scientists analyzing data from powerful telescopes, humans have always searched for meaning in the sky. Whether the universe whispers its secrets or hides them behind layers of mystery, the pursuit of knowledge continues. And in that pursuit, even uncertainty becomes a source of wonder.